when it comes to calculating energies, the calculations themselves are usually pretty straightforward. So we have here a whole bunch of worked examples of how to calculate some energies. So I have a question, a complete solution, and then I wrote down the steps that I took to actually solve the problem. So this first one, there's a 25 kilogram box on a table. There's a ceiling, and asks for the gravitational potential energy of the box relative to the floor and the ceiling. So this has one important point in that gravitational energy is always relative to some baseline. There's no absolute, or at least not in physics 11, there's no absolute gravitational energy. We always have to say what what baseline or what reference point that energy is relative to. So the equations Eg equals mgh. The mass is 25 kilograms. Gravitational field strength is 9.8. When this box is on the table, relative to the floor, the H is 1.2 meters. So we get a Eg of 294 joules. However, the question also asks us what the Eg is relative to the ceiling, which is above the floor. In that case, we have a different reference point. The reference is the ceiling, and it's above where the box is. In fact, it's if you subtract 3 meters from 1.2 meters, that tells you the relative height, and this is what we see here. The ceiling's 3 meters high, and that's kind of weird. Let's move that over. Move that. Oop. Okay. If the box is 1.2 meters off the floor and the ceiling is 3 meters, then the distance between the ceiling and the box is 3 minus 1.2, so that'd be 1.8 meters. So if we want to find out the gravitational field strength between the box and the ceiling, we have to use this value here, 1.2 minus 3. So we get a negative 441 joules. And it's negative in the idea that you'd actually have to put in energy to get it up to the ceiling. So you're kind of starting from a negative point. Whereas relative to the floor, it's a positive number. In other words, there's a whole bunch of energy. It's ready to do something to make it fall to the floor. Spring energy, again, it's pretty kind of straightforward. In this question, the first thing I think I had you do, or I'm asking, is the person would have to find the spring constant using Hooke's law. Once they have the spring constant, they can use the elastic potential energy equation. Okay. In this one, the box is being pushed up a ramp. Find the potential energy gained by the box. So here you're told that the box is pushed up a ramp that's 15 meters long. We're told that the angle of that ramp. So if Eg equals mgh, we'd have to find out the h, and we use that by doing a bit of trigonometry. So h is 15 sine 30. Okay, lastly, kinetic energy. Ek is 1/2 mv squared. Just plug the numbers in. That's pretty straightforward. A couple things to highlight though is you want to make sure you're always working in meters per second. So if you're giving values with speed of kilometer per hour, you want to make sure you change it into meters per second. And the last thing is when we look at kinetic energies that are changing and we want to know the increase or decrease of kinetic energy, we have to solve the two different kinetic energies separately. So it's the 1/2 mvf squared minus the 1/2 mv initial squared. You cannot do this. Those things are not equivalent. You can't just find the difference of the velocities and then square that. That doesn't work. All right, that should be enough to get you through the practice questions I'm asking you to do. If you have any problems, look carefully through these worked examples, and if you still have problems, you can send me a message and I will help you out.